Hello, back with another 21 and 21 project, 21 projects in 21 days. This one's the third part of the Azure with AI series. This one's on handling streaming events at scale. We're going to build a production grade event orchestration using fan-out patterns, retry policies, and dead letter handling, the same architecture Toyota uses for parallel processing. So this is mildly spicy. Should take about an hour and a half to go through. There's two previous parts to this. There's another part coming after this shortly. The previous two. So part one was building a streaming backend on Azure. Part two was adding moderation using AI to read comments and messages, and we hosted that with Azure. And the key concepts for today's project is Azure durable functions, Azure storage queues, the Azure Cosmos DB, and using Python. So a quick 30-second summary. Picture this: a popular streamer goes live and suddenly gets 10,000 new followers in 5 minutes. Without the proper architecture, your backend crashes, followers get lost, and the streamer's dashboard shows stale data. Toyota uses Azure durable functions in their Obeya AI system to coordinate parallel processing across engineering teams, designing powertrains. Fintech companies use them for distributed transaction management and payroll systems when you get a stateful workflows that can fan out to multiple tasks, wait for results, and handle failures gracefully. That's where durable functions shine. You'll build this exact pattern, creating orchestrations that fan out to multiple activities in parallel, aggregate stats in real time, and retry failed operations with exponential backoff. So what you'll build in this project, you'll build a streaming alert system that handles followers, subscriptions, and donations using Azure durable functions with a fan-out orchestration pattern. Why durable functions? Regular Azure functions are stateless. They run, finish, and forget, but stream event processing needs a coordination. So that is track with events, which events have been processed, run multiple tasks in parallel, and handle long-running workflows. Durable functions add state management on top of serverless. The orchestrator coordinates the workflow while the activities do the actual work. This pattern is how production systems handle millions of events without dropping data. You don't need prior experience with Azure functions or event-driven systems. This project teaches you queue-based load leveling, orchestration patterns, and real-time data aggregation, the same patterns that power enterprise AI systems at Toyota and distributed transaction processing at fintech companies. So you can use the ask feature here to check if this project is correct for you. Go and ask the AI there. So how you'll build it? First, you'll set up an Azure storage queue to buffer incoming events. Then you'll create a durable function orchestration that fans out to multiple activities in parallel, updating stats, sending alerts, and logging analytics. Finally, you'll add a stats endpoint that aggregates data from Cosmos DB. This is sort of the high level of what's going on. So you've got stream events going into a storage queue, then a durable function orchestrator, which is going to update stats, send alerts, and log analytics, and that's all going to be going into your database that we have set up. We're going to continue to add to, and then that goes to a stats API endpoint. By the end of this project, you'll have a working event queue that buffers stream events during traffic spikes, durable function orchestrations with fan-out patterns for parallel processing, real-time stats aggregation with Cosmos DB, and if you do the secret mission, which we will do in this project, or in this video, sorry, retry policies, and dead letter handling for failed notifications. So you can walk me through the quiz first. I'll do it at the end. Okay, step 0 before we start step 1. In this project, you'll build an event-driven streaming backend using Azure durable functions, where you can buffer incoming stream events, followers, subscriptions, donations, using a Azure Storage Queue, processing events in parallel using fan out/fan-in pattern, aggregate real-time stats in our DB, and handle failures gracefully. And a storage queue for Azure is a messaging service that's stored in large numbers of messages. It enables asynchronous communication between application components, allowing them to send and receive messages reliably, even if parts of the system are temporarily unavailable. Moving to this definition here for fan out/fan-in, an architectural approach where a single task is broken into multiple subtasks, fan out, processed independently, and then brought together in fan in to complete the task. What are we doing in this project? This project I'm going to build an event-driven streaming backend using Azure durable functions. Which can buffer incoming stream events, fan out, it helps because it allows large tasks to be broken into subtasks. What are we building in this project? In this project, I'm going to build an event-driven streaming backend using Azure durable functions, which can buffer incoming stream events, process events in parallel, that's fan in/fan out, and then it helps because it allows us to break those larger events into smaller subtasks. Cool. So we're going to build your event buffer. Every enterprise system that handles unpredictable traffic uses some form of message queue. When Toyota engineering systems need to coordinate work across multiple teams, or when fintech platforms process thousands of payroll transactions, queues prevent the system from getting overwhelmed. You'll create an Azure Storage Queue that buffers incoming stream events. This is the first layer of resilience in your event-driven architecture. So what is a message queue and why do we need one? A message queue is like a waiting room between event producers and event consumers. When a streamer goes viral and gets thousands of new followers in seconds, the queue holds all those events temporarily. Your backend can then process them at a steady pace instead of being overwhelmed. This pattern is called queue-based load leveling. It decouples the rate which events arrive from the rate at which they're processed. Without a queue, a sudden traffic spike could crash your server or cause events to be lost. So, if you have done, depending on if you've done parts 1 and 2, from this, you can go down different paths. There's steps here for each, but I've completed parts 1 and 2, and I do have a logged in account. If it's deployed, the function is I have a Cosmos DB. Those endpoints are working, and then AI moderation with Gemini is integrated, so we're good to go down there. But if you haven't done those bits, then definitely head down these tracks there. So in the step, you're going to set up a storage queue with alerts. verify your function app can connect to the queue. So I'm setting up a storage queue for alerts. A message queue helps because it decouples the rate at which events come in from the rate at which they are processed. Queue-based load leveling means, let's see what it says up here about that. A sudden spike in traffic doesn't result in systems being overloaded. What are we doing in this step? In this step, I'm setting up a storage queue for alerts. A message queue helps because it decouples the rate at which events come in from the rate at which they are processed. Queue-based load leveling means that a sudden spike in traffic doesn't result in systems being overloaded. Cool. Alright, I will just put Azure on this side. Project guide over there. Cool. Okay, so we're going to navigate to our storage account. Open the Azure portal and sign into your account. Search for storage accounts in the search bar. So we'll just select our existing storage account. So we're going to be creating alerts. And why do we want to reuse the existing storage account? Your function app already has a storage account that was created in part 1. Azure storage accounts can hold multiple services, blobs, queues, tables, etc. Adding a queue to your existing account will keep everything organized and avoid unnecessary resource sprawl. I'm going to create the alerts queue. So we'll go over to storage browser. We will select queues. These are just for testing stuff. Click add queue, and then call it alerts. So why is it called alerts? This queue name must match what the function code expects. We're calling alerts because it will hold stream alerts that can be followers, subscriptions, donations. In the next step, you'll write code that listens specifically to this queue name. Cool, so I'll send a screenshot here of this. I created a queue by what's this called again? It's storage accounts. Going to storage accounts. Streaming backend. because we will write refers to this name directly. Cool, so we're just going to check your function app connection. So if we go up here, go to function app, select our app, and just go to, where is it? Settings. Environment variables. We should look for Azure Web Jobs Storage in the list. So we see that, so we're good to go. If you don't, there's some steps here to add it. Nice, your function app is already connected to the storage account. Since the queue is in the same storage account, your function will automatically be able to read and write from it. Cool. So I verified my function app can connect by checking Azure Web Jobs Storage from what is saved as a environment variable in the function app. Azure Web Jobs Storage is important because it means my queue can talk to my function app can talk to my queue. Cool. How did you verify your function app connection? I verified my function app can connect by checking the Azure Web Job Storage is saved as an environment variable in the functions app. Azure Web Job Storage is important because it means my function app can talk to my queue. Cool. Step 2. So we're going to orchestrate parallel processing. This is where the real power of durable functions comes in. Toyota chose durable functions for their Obeya AI system specifically because of its ability to fan out work across multiple agents in parallel, then aggregate the results. So you'll build a durable function orchestration that fans out to these 3 activities simultaneously, updating stats, sending alerts, and logging analytics. The fan out pattern is how you process work in parallel without losing track of any pieces. What are durable functions? Regular Azure functions are stateless. They run, complete, and forget everything. But when you need to coordinate multiple steps, run tasks in parallel, or track progress over time, that's where durable functions come in. They add state management on top of regular functions, letting you write complex workflows that can pause, wait for other events, and resume where they left off. So in this step, you're going to create a queue-triggered function, build the orchestrator function, implement activity functions for stats, alerting, and logging. Cool. Doing that to start. Orchestrations. The fan out / fan in pattern means I am able to run functions for stats, alerts, and logging in parallel. Or I could say run functions in parallel. The 3 activities are stats, alerts, and logging. So in this step, I'm creating a queue-triggered function to start orchestrations. The fan out / fan in pattern means I am able to run functions in parallel. The 3 activities are stats, alerts, and logging. So again, the same architecture we were looking at before. Before we code, let's understand what we're building. When an event arrives in the queue, it triggers a starter function that kicks off orchestration. The orchestrator then fans out to run multiple activities in parallel, updating stats, sending an alert, and logging analytics. This is again the same architecture diagram we saw before, but that's just, yeah, it's important to have a little second reflection on what's actually going on here. So what is the fan out pattern? Fan out, fan in pattern, sorry. Fan out, multiple tasks starting at the same time. Fan in, wait for those to finish, and then combining them all to get the response you want. Set up your development environment. Before writing any code, you have required tools. Check you have the required tools. Run this command in your terminal to check. Open that up. So I see a version number. If you don't, some steps here as to how to install this. Yeah, so these are the Azure function core tools. They're required. They're like the CLI tool for Azure, effectively, that we're going to use to deploy functions that we have been for this project so far. So, yeah. Oops. Cool. We also check we have Python, which we do. Great. And you can install Python, some steps here as well. Cool. So we're going to open Cursor. Just put it on the side of the screen. Cool, and we're going to click. I've already got the folder open. I'll just close it to follow along. Here we go. File, close folder. We select Open Project. Click there too. I'll go to Desktop, and then I'll go to Streaming. Streaming Backend RG. That's what I called mine. So we're here now. We opened it. You should see our project files in the sidebar, including functions app.py and requirements.txt from part 1. If you don't have Cursor, you can go install it from that link. It's an AI-powered code editor. Cool, so we're going to create the durable functions app. So we just opened Cursor's chat panel with that command, or by clicking this little arrow, or the cursor icon up there, and then we'll send that prompt off. So what's happening in this prompt? This prompt asks Cursor to create a complete durable functions workflow, a queue trigger that starts orchestration when events arrive, an orchestrator that coordinates parallel processing from a fan out / fan in, 3 activity functions that do the actual work independently, and then an HTTP endpoint for manual testing. The fan out pattern runs all activities simultaneously, then waits for to complete before returning. And then Cursor might also ask you to click accept here, which we'll do if it pops up. So what these decorators mean, you'll see these in the code. We just saw one there when Cursor's writing it. So the app queue trigger tells Azure functions to run this code whenever a message arrives in specific queue. Durable client input injects a durable function client that can start and manage orchestrations. Orchestration trigger marks a function as an orchestrator that coordinates the workflow. Activity trigger marks a function as an activity that does the actual work. So you can see a queue trigger there. Just giving it some time to go through and do this. So what do the different function types actually do? A queue trigger starts when messages arrive in the queue. The orchestrator coordinates the workflow, e.g. what functions are running when. The activity functions do, or let's say mark a function for being to be the one executed, the one that actually does the work. Also do a web search there, I think just checking the syntax is correct. So what do the different function types actually do? A queue trigger starts when messages arrive in the queue, and orchestrators coordinate the workflow, e.g. what functions are running when. The activity functions mark a function to be one to be executed. That's the one that actually does the work. Cool. Just give cursor a second here. Cool, so we can open requirements.txt here, and we can see if if cursor updated it correctly based on the changes that were made to functions app.py. So there's Azure functions, Azure Cosmos, that's for the DB, that's for the functions app. This is just a common request library, and this is what's being added now. So Azure durable functions. Yeah, I think we're supposed to. I think it might have got this around the wrong way. We can check. I'm actually not sure. I think it's functions durable. And I think it did this when I was testing this project out, and it caused me a little trouble. So make sure it's around this way. I don't know why cursor wants to do it around the other way, but it is the other way around, like this way around, and that's explained here. Oh, new terminal. Cool. So running this, I'll start from the beginning. Deploy and test. Deploy your function and test the orchestration. Open the terminal and cursor by pressing Control plus apostrophe. Make sure you're in your stream backend project folder. Check you're logged into Azure with this. So I see my subscription. That's great. Yeah, if you see something which asks you to run AZ Azure login, you can do that. There's some steps here to log in, and what you'll see. Yeah, what you'll see there, but I'm already logged in, so that's all good. Cool, so now we're I'll clear this, and then we'll run our deploy command to Azure with our function tools from Azure. So this should return something like this. It should take a minute or two, not too long, and then we're going to copy the URL if we haven't already got something in there. Cool, so it's just finished deploying and it's just given us a list of the functions that have been deployed, which is the ones we added, so that's great. Cool. And we can copy one of these URLs here, it'll be the same, but paste it in there, and then we can send a test event. Hopefully this works. Let's have a look. Cool. So I'm going to select A. You can select Y. Either option, but A just like accepts the security warning for all. Cool. So we can see we get accepted, which is good. Nice. If you're having issues with that, then yeah, there's some a common thing is that you'll deployment might complete, or might say retried a few times then complete, and then it'll say successful, but it won't list any functions. That's almost always because the cursor's written some code incorrectly. Might have duplicated a function. It might have decorators used incorrectly. Might have, your requirements.txt these names might not be correct, or this name specifically, because it just was the one that we just added. There's some tips there. Definitely reach out to the community, or use the ask feature there for any help. But we're going to go on this track because it worked all good for us. The response includes a status query get URI. This is a URL that you can use to check the orchestration status. Copy that URL and paste it into your browser, or run the invoke command we just saw. You should see runtime status complete. You do, which means the orchestration has finished successfully. Why use status query get URI instead of Azure portal? The Azure portal, you can have delays, and that just queries immediately. Cool. So we can just send this. How did you verify your orchestration works? I tested the orchestration by sending an invoke/curl command to the event endpoint. The showed a completed status. This confirms the new say durable function was set up correctly. How did you verify orchestration works? I tested the orchestration by sending an invoke/curl command to the event endpoint. The status query get URI showed a completed status. This confirms that the Azure durable function was set up correctly. Cool. Oops. Step 3, aggregate real-time analytics. So Netflix processes billions of viewing events daily to power their recommendation engine. Spotify aggregates listening data in real time to update personalized playlists. Your orchestration is processing events in parallel. Now you need somewhere to store the results and aggregate them into meaningful metrics. Why do we need a database for analytics? Right now, your activity functions process events but don't persist anywhere, so they don't get saved. Cosmos DB is a good choice because it's serverless, like your functions, scales automatically, and integrates well with your Azure functions. So in this step, get ready to set up Cosmos DB for storing analytics, implement the stats aggregation endpoint, and test with simulated events. So in this step, I'm setting up Cosmos DB to store analytics from my durable functions. The analytics containers stores data, we'll say metadata from functions on runtime. The stats container stores information helpful for understanding potential errors run into by users. What are we doing in the step? In the step, I'm setting up Cosmos DB to store analytics from my durable functions. The analytics container stores metadata from my functions on runtime, The stats container stores information helpful for understanding potential errors ran into by users. Cool, we're going to set up the new Cosmos DB container. So we'll jump back to this in the Azure portal, search up Azure Cosmos DB. Select that. We'll go to Data Explorer. We'll click New Container. We're going to create new stream data, container ID, and analytics, and a partition key of stream ID. That's what we've been using. I'm going to click OK. Once that completes, we'll create another container. It shouldn't take too long. Cool. So another container. This time we're going to be using the existing stream data. We're going to call the container, or container ID is going to be stats, and the same stream ID to make sure that syncs with everything else. So why two containers? We use separate containers for different access patterns. Analytics stores raw events, good for detailed reporting and debugging. The stats container stores aggregated counts per stream, fast lookup for real dashboards. And as we spoke about, the stream ID partition key groups data by stream. So queries for a specific stream are fast. Cool, so now we're going to add the Cosmos DB connection string. In your Cosmos DB account, go to settings, then keys, settings, keys, and just be careful, we're going to get the primary connection string, not the primary key. I made that mistake when I was doing this the first time. So yeah, we'll get the primary connection string, we'll copy that. Yep, cool. So now we'll go to, spell that right, functions app. Go on to, functions app, streaming backend, so select the one you're currently working on. Let's select add. We can the name Cosmos DB connection. I'll just paste that in. I think that's correct. I wonder if it's supposed to be like that. I'm not actually sure. And that's what I copied, so give it a go, and if it doesn't work, we can go debug. That's fine. Why a separate connection string? You already have a Cosmos connection string from part 1. The new Cosmos DB connection variable connects the same Cosmos DB account, but we use the stream data database. Using a separate variable makes it clear which database each part of your code connects to. Cool. So upload a screenshot of your connection string config. Take a screenshot of this. Why did we use two separate containers? I created two containers because One is for my, we can actually go look at the Cosmos DB here. One is for my stream data. Analytics. Other is for my messages, messages effectively, and that includes violations. Partition stream ID, partition key stream ID groups data by sort of per stream. Why do we use two separate containers? I created two containers because one of them is for my stream data analytics, the other is for my messages, which includes violations. And the partition key stream ID groups per stream, groups data per stream. Update the activity functions. So now let's update your activity functions. We'll go back to cursor, send this off. So we'll send that to cursor. What's happening in this prompt? This prompt asks cursor to connect your activity functions to Cosmos DB. The log analytics activity saves every event in historical analysis. The update stats activity maintains running totals. Both activities use the same partition key we set up. And so we'll see an upsert item. Upsert is a combination of update and insert. If a documentation with an ID already exists, it updates it. If it doesn't, it creates a new one. This is perfect for our stats document. It's very similar to the fetch, patch, compared to like a direct update in an API. Cool. So if you're prompted to accept any changes, you can do that. Next, we'll be adding the stats endpoint. So now add an HTTP endpoint to retrieve stats for a stream. We'll just let this finish, shouldn't take too long. A final one check. So what's happening in this prompt? This prompt adds a read endpoint, so you can query the aggregated stats. It handles the case when no stats exist, as we were speaking about before. Cursor will add the endpoint to your functions app.py file. And if prompted, we can accept any changes. Now let's, once that finishes, we'll go and deploy again to Azure. So we'll just send this off, and this shouldn't take too long to deploy. It can take a few minutes though, but we should see all these functions here when it finishes. Cool, so that deployed, you can see the functions being listed here, which is great. Yep, so we can just double check that Azure Cosmos is in our requirements.txt. It should be, because we've been using Cosmos up until this point with previous projects, but if it isn't, you certainly should add it. Cool. Now we're going to test with simulated events. So we've got our URI there, and we're going to send off some stuff here. I'll just close this so we can look at it a bit better. So we can see an accepted there. That's good. I will note that we'll figure out at the end if this is really work, because we're going to run a test, and if it doesn't, then it's probably the extra bit of text which I wasn't sure if it was correct to add to the to the environment variable. My guess, we can go and change that, and I can show how to fix that. But looks to be working fine now. So then we'll send a donation event. And now we can check the stats. So we should see not zeros, a little like this. But if we do see zeros, it's likely because that environment variable's not configured, so the function app that we're sending this to can't actually communicate to the new database we set up in Cosmos DB, the one for analytics. But let's have a look. Okay, cool, that worked. So that is all linked correctly, which is nice. Very good. If you're having troubles, you can go to the monitor section, and this is what I ran into when I was setting this up. This wasn't configured correctly, so yeah, definitely check that. You copied the right thing to paste in there. Cool. Your stats aggregation is working. Verify in the Azure portal. Go to Cosmos DB Data Explorer. You can check your data there. So we'll just upload a screenshot of this response. How did you verify stats aggregation worked? Tested by sending a invoke/curl command. The response showed cool. I tested by sending an invoke/curl command to the events API and calling the stats endpoint. The response showed stream ID, follower count of 1, a sub count, and a total donation count. Cool, so now we're going to do the secret mission. Handle failures like the pros. Your orchestration works when everything goes right, but what happens when an external notification service goes down, when a database connection times out, production systems fail. What matters is how they recover. Stripe processes billions of payments by using retry policies with exponential backoff. When a payment processor is temporarily unavailable, they don't crash, they wait and retry. Events that permanently fail go to dead letter queues for investigation. In the second mission, you'll add the same production grade handling to your orchestration. So this is sort of the what we've got set up here. So the orchestrator sends an alert. It'll retry a number of times, but it can't complete immediately, and then it'll the exponential back off, so the time interval will increase, and then it's getting added to a dead letter queue. Yep. So Stripe handles billions of payments by assuming failures will happen, and building systems that recover automatically. When a payment process fails, it is temporary unavailable. The retry policies wait exponential time, so 1 to 4 seconds, giving the server time to recover. Events that temporarily fail get routed to a dead letter queue for manual investigation, a technique in Amazon SQS popularized for the enterprise messaging. You'll implement these exact patterns when your notification service goes down. The orchestrator won't crash, it'll just retry intelligently and preserve failed events. In the second mission, get ready to add retry policies, create a dead letter queue, implement dead letter handling, and test failure scenarios to verify your error handling worked. So in the second mission, I'm adding retry policies with exponential backoff. Retry policies help because if the event fails, if the service is down and the event fails, the system will wait and retry. Dead letter queues are for logging errors like this, so we can investigate what happens later down the line. Cool, so in the second mission I'm adding retry policies. Retry policies help because if a service is down, the system can retry. Dead letter queues are for locking errors like this so we can investigate what happens later down the line. Understanding retry patterns. Not all failures are equal. Some are temporary and some will succeed if you retry. Others are permanent and will never succeed. So what is exponential backoff? Instead of retrying immediately, exponential backoff waits progressively longer between retries. This gives the failing service time to recover while preventing a thundering herd of retry requests. Cool, so we're going to add retry policies now. So I'll open this chat back up. Durable Functions has a built-in support for retry policies. Let's add one to the send alert activity, which is most likely to fail. External notification services are often unreliable. So we'll send this prompt in Cursor's chat. Cursor will modify your functions app.py. Click accept on the changes. What's happening in this prompt? This prompt asks Cursor to add automatic retry logic to your notification activity. If send alert fails, it will automatically retry up to 5 times. After 5 failed attempts, it gives up. Other activities don't need this because Cosmos DB has automatic built-in retry logic. So Python SDK for durable functions only supports 2 options. First, retry interval milliseconds and max number of attempts. Advanced options like backoff coefficient and max intervals are available in C# or .NET, but not Python. What these options mean, you'll see this in the code. First retry in milliseconds, how long to wait before retry. Max number of attempts, just number of attempts is going to go through before retrying. Cool, in the Azure portal, navigate to your storage account in the left menu, data storage, click queues, click plus queue. So we'll jump back to this. Cool, so we'll go to the storage account. So we'll go to select on the backend storage we're working on, go to storage browser, go to queues, create another queue. We'll call this alerts dead letter. Click OK. Why a dead letter queue? Dead letter queues let you investigate why events failed. You can review the original event data, fix underlying issue, reprocess the events manually, and set up alerts when events land in the dead letter queue. Cool, so now we can update our code. So now update your orchestrator to catch failures and route them to the dead letter queue. Cool. So anytime that retry happens effectively, we're going to reroute it to the dead letter queue. What's happening in this prompt? This prompt asks Cursor to add dead letter handling. When all retries are exhausted, the failed event goes to the dead letter queue. The queue message includes the original event, error message, orchestration ID, and orchestration ID. You can review these failures later and reprocess them after fixing issues. Cursor will modify your functions or app. You can click apply if it asks. Why base64 encode the message? This is something that happened in a prompt. While JSON is already UTF-8, base64 encoding ensures that any special characters or binary data event won't be corrupt. How does dead letter handling work? I created a dead letter handling queue by creating a new queue in my storage account. Failed events go there because this allows me to monitor or understand why events which maxed out their retry limit did so. The event payload includes information regarding why the event failed, so I can attempt to replicate. How does dead letter handling work? I created a dead letter queue by creating a new queue in my storage account. Failed events go there because this allows me to understand why events that maxed out their retry limit did so. The payload includes information regarding why the events failed, so I can attempt to replicate. So we'll just make sure that Azure Storage Queue has been added to requirements. We just saw that, so that's good to go. If you didn't see that, then you can go and add that and go down that route there. Oops. Here we go. So we can test a failure scenario. So if we open this prompt up, we can update the send alert activity to simulate a failure by raising an exception with the message notification service unavailable. This is temporary for testing and retry logic. Cool. So cursor will modify the send alert function, click accept to apply the changes, and then we're just going to deploy this again. So I'll just clear this, and then once that's finished, we can deploy the function. Shouldn't be too long. Cool. So this is just going to go and deploy. Shouldn't be longer than a couple of minutes. Yeah, and that'll go push out the code just set up to create sort of a false alert to Azure, so we can actually run it and test it. Cool. So that's deployed. Now we can wait. So once deployment is completed, we can send a test event. Just close this so I can see a little better. Cool, so it looked like it worked, which is great. Verify the dead letter queue, so now check the failed event was sent to the dead letter queue. In the Azure portal, we'll go back to where we were. In the left menu, data storage, click queues, click on alerts dead letter. If you get a permission error, like the one noted here, that's okay. There should be a button which just lets you switch the account ID. Cool, so we can see that's come to the dead letter queue because it failed, which is exactly what we want. The message contains everything you need. Do you have failures, the original event that failed, and the error message just explaining why, and the orchestration ID to trace it in logs. Cool, so we'll just send a screenshot of that. How did you verify the error handling works? I verified by simulating a failure, by updating a function to force a service down. The dead letter queue showed information allowing me to fix this potential error. This helps me debug issues because I can track errors that have occurred and how they occurred. So I verified by simulating a failure. I updated a function to force a service down. The dead letter queue showed information allowing me to fix a potential error, and this helps me debug issues because I can see errors that have occurred and how they occurred. Cool, so we can just send this prompt back to restore, well, not to, not to the console, to restore, and then we can redeploy. What did you just build? You've implemented the same error handling pattern used by Stripe, Discord, and Netflix. It was retry policies, we just talked about dead letter queues, so that's where everything that fails these retry logic goes, and graceful degradation, so your orchestration completes even when activities fail. Failures happen in every production system. The differences between an amateur and professional system is how they recover. So production tips, extra stuff here. You can set up alerts when events land in the dead letter queue, so an email or something. You create reprocessing functions to retry dead letter events after fixing issues. Add circuit breakers, so to fail fast when a service is completely down. And implement item potency, so retries don't create duplicate data. Cool. So we can deploy this function again. It's not really crucial to what we're doing. We're already finished, but you did it. Or waiting for it to finish isn't crucial for finishing the project. You've built an event-driven streaming backend with async processing using Azure durable functions. You've learned how messages buffer, message queues buffer events, and prevent system overload, Azure durable functions, and fan-out, fan-in patterns. Cosmos DB for NoSQL data storage, data aggregation patterns for storing raw events versus maintaining running totals, event-driven architecture, so decoupling producers from consumers for scalable systems, and this is the sort of thing we touched on before, where an alert will just retry or go to the dead queue once it's finished retrying. If it doesn't get to the end, or if it completes, that's good too. So we'll just do a quick quiz. What is the primary purpose of using an Azure Storage Queue? To provide persistent storage, to orchestrate parallel processing of events, to buffer incoming events, stream events, and prevent the backend from being overwhelmed, to store real-time stats, to buffer incoming stream events, and prevent backend from being overwhelmed. I would say it's this one, but this does look like maybe. Cool. What does the project use two separate Cosmos DBs containers for? To separate data sensitivity level, to allow teams to manage their own data, to store different types of data and different across patterns, raw, and aggregate accounts and stats. I think it's this one. Cool. What is the primary function of the upsert item? It only inserts when a document if one same ID does not already exist. It updates the documents if it exists, or inserts a new one if not. Pretty sure it's that. It deletes document if it exists. Nope. It only updates an existing documentation if one with the same ID is found. It only inserts a new document if one with the same ID does not already exist. It updates a document if it exists. I feel like it's saying very similar things. I'm going to go with B. According to the second mission section, what production-grade error handling mechanisms are suggested for the orchestration? Shifting all processing to a backup region immediately upon any error. Disabling error logging to prevent system slowdowns. Using retry policies with exponential backoff and dead letter queues for permanently failed events. Implementing immediate server restarts and manual data recovery. So according to the secret mission section, what production-grade error handling mechanisms are suggested for orchestration? Using retry policies with exponential backoff. I think it's that one. Disabling error logging, shifting all processing to a backup region, implementing immediate server restarts. Go this one. In the context of Azure durable functions, what is the role of an activity function? It initiates the durable function orchestration when an external event occurs. It manages the state of history, defines workflow logic, coordinates the execution, performs the actual work or tasks within the orchestration. I think it's this one. Cool. How do Azure durable functions contribute to processing stream events in parallel within this project. They allow direct synchronous communication between events. They provide a stateless execution. They automatically scale the underlying virtual machine. They enable fan-in, fan-out activities. I think of that one. Cool. That was actually a really good quiz. So what's next? Part 4. Get ready to add real-time notifications to your streaming platform with Azure Signal R. Cool. So we can click Mission Accomplished. See a nice, cool animation here. If you want to share your documentation, that's great. Just go back to here. Scroll down again to the bottom so we can read the cleanup steps. So, yeah, before you go, you can Azure functions on the consumption plan only charge when functions run, so costs are minimal. However, if you created a Cosmos DB account, it has a small ongoing cost. If you want to keep your resources, you can go down here. If you want to delete everything, you can go down here. That's cool. You'll need to recreate resources for the future projects if you go down this one, but that's fine. So we can just walk through these here. What were the key tools and concepts I used? Key tools I include using Azure durable functions. And Cosmos DB. Key concepts I learned include partition keys, deployment from CLI, environment variables, and APIs. How long did this project take you? This project took approximately 1 hour. The most challenging part was setting up the Cosmos database. It was most rewarding to see my messages persist in the Cosmos DB. With the skills I learned, I want to build the rest of the streaming back end. I did this project to learn how to use Azure to set up basic serverless functions. Another Azure skill I want to learn is AI integration. Cool. All right. Well, thank you guys for following along. Yeah, I really hope you enjoyed the project. I think it's a real cool project. I think that yeah, setting up durable functions is super useful. Understanding how storage queues work is also very, very useful. Yeah, stay tuned for another Azure project on analytics at the end. Next time tomorrow. Yeah, thanks so much for watching. I'll see you guys later.